Hello dear class 10 students, I hope you all are studying well. So we have already completed the chapter Human Eye and the Colorful World. So today we are going to start the last lesson number 5, where we will solve some numericals. Okay, now let us see the first question. The far point of a myopic person is 80 cm in front of the eye. What is the nature and power of the lens required to correct the defect? Etia tumaluke question to chua. So person jone juntu eye defect suffer korise, he eye defect to hoise myopia. Aru ei defect tut image to retina front dot form hoy. So myopia to correct koribole hole ami ekhon concave lens use korim. So etia object distance to kot thakibo? Yes, infinity. Aru image distance dia ase, that is v equal to minus 80 cm. So question tut ki uliabole dise? Nature and power of the lens. So এই কোৱেশ্চনটোত আমি দুটা ফৰ্মুলা ইউজ কৰিম, লেন্সৰ ফৰ্মুলা আৰু পাৱাৰ ফৰ্মুলাটো। ওকে, সো পাৱাৰ ফৰ্মুলাটো হৈছে p = 1/f আৰু মনত ৰাখিবা পাৱাৰৰ ক্ষেত্ৰত ফোকেল লেংথটো সদায় মিটাৰত ক্যালকুলেট কৰিম, ঠিক আছে। আৰু লেন্সৰ ফৰ্মুলাটো হৈছে 1/v - 1/u = 1/f। সো আই হোপ ইউ অল নো দিস ফৰ্মুলা। ওকে, সো ফাৰ্ষ্টতে আমি লেন্সৰ ফৰ্মুলাটো ইউজ কৰি ফোকেল লেংথটো লিয়াম। ওকে, and after that we will find out the power. So it is solution to swa. So 1/-80 minus 1/infinity, because we know that u equal to infinity, right, which is equal to 1/f. Therefore 1/80 minus 0, and anything divided by infinity is equal to 0. Therefore 1/-80 equal to 1/f. Therefore focal length f equal to minus 80 cm. So etia ami easily power to liabo parim, right? So p equal to 1/f. So focal length to jihetu centimeter ase, so first te ami meter le convert koribo lagibo. Okay, which is equal to 0.8. So p equal to 1/0.8, it is minus 0.8. Okay, which is equal to minus 10/8. Therefore p equal to minus 1.25 diopter. So a concave lens of focal length 80 cm is required and the power of the lens is 1.25 diopters. So concave lens conor focal length to hoise 80 cm aru lens conor power to 1.25 diopters. Is it clear? Alright. It is second question to swa. So a myopic eye has a far point 2 meter. What type of lens in spectacles would be needed to increase the far point to infinity? Also calculate the power of lens required. Etia tumaluke question tut ki dia hoy ase hetu swa. So short sightedness thoka person ejonor far point dia ase 2 meter. So myopia tuk short sightedness buliu koa hoy. I hope you remember this. So person jone infinity thoka objects bur he dekha pai. So object distance u to ki hobo infinity, right? Aru v to ki hobo image distance v equal to minus 2 meter. So we have to find out the focal length and power. So I hope tumaluke etia question to buji pala. So a question to question number 1 or logot similar, right? So etia directly tumaluke lens aru power formula to use korile focal length aru power to pai jaba. So solution to swa, lens formula to ami use korile 1/v - 1/u = 1/f, right? So v to kiman dia ase -2. So 1/-2 minus 1/infinity, which is equal to 1/f. Aru ami janu je anything divided by infinity is equal to 0. Therefore 1/-2 equal to 1/f. Therefore focal length f equal to -2 meter. So focal length to jihetu negative, so he karne lens khon hoise concave lens. So a concave lens is required in spectacles to increase the far point to infinity. Now we can easily find out the power, right? So p equal to 1/f. Etia focal length ami kiman palu -2. Therefore p equal to 1/-2, which is equal to minus 0.5 diopters. So a concave lens of focal length 2 meter is required and the power of the lens is 0.5 diopters. So defect to rectify koribor karone concave lens khonor power to minus 0.5 diopter is required. Am I clear, guys? So defect to rectify koribor karone concave lens khonor power to -0.5 diopter is required. I hope there is no doubt. Alright, now see the third question. The near point of a hypermetropic eye is 1 meter. What is the nature and power of the lens required to correct this defect? Assume that the near point of the normal eye is 25 cm. Etia question to kiki dia ase swa. So hypermetropic eye near point dia ase 1 meter. Right? Aru ki assume koribo koise? Normal eye near point to assume koribo koise 25 cm. So etia object distance to kiman hobo? Yes, u equal to -25 cm. Aru image distance v equal to -1 meter. So yat jihetu image to meter ase, so first ate ami centimeter le convert koribo lagibo. So don't forget this, okay? So etia ami image distance kiman pam? V equal to -100 cm. Is there any doubt? Okay. So etia question to ki uliabole dise? So a hypermetropia to correct koribole hole ami ki lens use koribo lagibo aru lens khonor power to kiman. So a question to easy hoy, right? Because malike yat simply lens aru power formula to use korile answer to pai jaba. Etia solution to swa. Etia a lens formula to apply kori ami focal length to calculate koribo lagibo. So guys, video to tumaluke pause kora aru calculation to nije try kora. Alright, let me help you out. So calculation to korar pisot ami focal length to palu 33.3 cm. So etia power to calculate koribole hole first ote ami a focal length to centimeter pa meter le convert koribo lagibo. Right? So convert korar pisot ami palu 0.33. Therefore power equal to 1/0.33. So etia decimal to remove koribole hole we can write 100/33. Therefore power equal to 3 diopter. Etia swa jihetu ami focal length to positive palu, so he karne lens khon hoise convex lens. So convex lens khonor focal length to 33.3 cm. Aru convex lens khonot juntu power lagibo he power to hoise 3 diopter. Is it clear? Alright. Now look at the fourth question. An eye has a near point distance of 0.75 meter. What sort of lens in spectacles would be needed to reduce the near point distance to 0.25 meter? Also calculate the power of lens required. Now, is this eye long-sighted or short-sighted? So guys, can you try by yourself? Okay, etia swa question to kiki dia hoy ase. So near point distance of the eye to dia ase 0.75 meter. Right? So etu hoise image distance. So jihetu unit to meter ase, so first ote ami image distance to centimeter le convert koribo lagibo, which is equal to -75 cm. Aru ki dia hoy ase desired near point distance dia ase 0.25 meter. So etu hoise object distance. So jihetu object distance to meter ase, so etu ami centimeter le convert koribo lagibo, which is equal to -25 cm. So now what we have to find? Yes, the nature and power of lens. So to determine the type of lens needed and the power required, we can use the lens formula and the concept of power of a lens. Right? I hope you can do it by yourself now. It is solution to swa. So 1/v minus 1/u equal to 1/f. So v value to dia ase -75 cm aru u value to hoise -25. So after doing the calculation, we got focal length f equal to 75/2, which is equal to 37.5 cm. So jihetu focal length to positive, therefore convex lens is required. Etia lens khonor power to calculate korar agot ami focal length to centimeter pra meter le convert koribo lagibo, right? Which is equal to 0.375. Therefore, P equal to 1/f, which is equal to 1/0.375. Now, by removing the decimal, which is equal to 1000/375. So, power equal to 2.67 diopter. So, the required power of the lens is 2.67 diopters. Etia question to last part to ki hudise, is this eye long-sighted or short-sighted? So can you tell me? Yes, it is long-sighted or hypermetropia. So reason to hoise amar eye juntu near point, he near point to desired near point ke durot ase. So it indicates that the person is long-sighted. I hope there is no doubt. Great. So to correct this, a convex lens is needed. Okay guys, etia question number 5 to swa. A person needs a lens of power minus 5.5 diopters for correcting his distant vision. Okay. So for correcting his near vision, he needs a lens of power plus 1.5 diopter. So what is the focal length of the lens required for correcting his distant vision and near vision? So guys, a question to easy hoy. So tumaluke first question to ki dia ase hetu swa. So question to distant vision correct kora lens khonor power to dia ase, that is P1 equal to minus 5.5 diopter. Okay? Aru ki dia hoy ase? So near vision correct kora lens khonor power to dia ase, that is P2 equal to 1.5 diopter. Etia swa question to ki uliabole dise? So distant vision aru near vision correct kora lens khonor focal length. So basically we have to find the value of f1 and f2. So to determine the focal length of the lens, we can use the power of a lens formula, that is P equal to 1 upon f. Okay guys, etia tumaluke solution to swa. So first ami distant vision or focal length to uliam. Therefore P1 equal to 1 by f1. Therefore f1 equal to 1 by P1. Etia P1 or value to kiman dia ase minus 5.5. So guys, do the calculation now. So after calculating it, we got f1 equal to minus 0.1818 meter. So tumaluke power to khetrot hodai monot rakhiba focal length to ami meter likhim. Okay? Okay. Now next let us calculate the focal length for near vision. Therefore P2 equal to 1 by f2. So P2 value to kiman dia ase 1.5. Therefore f2 equal to 1.5. So calculate korar pisot ami f2 value kiman palu 0.667 meter. So the focal length for distant vision is minus 0.1818 meter and the focal length for near vision is 0.667 meter. Am I clear guys? Okay. Etia question number 6 to swa. So a person with myopic eye cannot see an object beyond 1.2 meter distinctly. What should be the type of corrective lens used to restore the proper vision? So question 2, myopic eye person ezone 1.2 meter ke jodi durot thake object to tetia distinctly dekha nepai. So question 2 hodise kunkhon lens use korile proper vision to restore hobo. So a question 2 easy hoy. Yat object distance to hobo infinity, right? Aru image distance to hobo minus 1.2 meter. So we have to find nature of the lens and power. Etia tumaluke solution to swa. So first ami lens formula to apply kori focal length to calculate korim. Etia solution to swa 1 by f equal to 1 by v minus 1 by u. So v value to hoise minus 1.2 aru u value to hoise infinity. Therefore 1 by f equal to minus 1 by 1.2 aru 1 by infinity is equal to 0 because any number divided by infinity is equal to 0. Therefore 1 by f equal to minus 0.83. Etia ami janu je power formula to hoise p equal to 1 by f, right? So jihetu yat focal length to meter ase, so directly ami power to kiman pam minus 0.83 diopter. Therefore to restore the proper vision, a concave lens of power minus 0.83 diopter should be used. So proper vision to restore koribole concave lens kon use koribo lagibo of power minus 0.83 diopter. I hope it is clear. Okay, it is last question to swa. The far point of a myopic person is 150 cm in front of the eye. Okay, so calculate the focal length and the power of the lens required to enable him to see distant objects clearly. So question 2, myopic person joner far point to dia ase 150 cm. So a 150 cm to hoise image distance, that is v equal to minus 150 cm. Etia ami a centimeter to meter le convert korim. Therefore v equal to 1.5 meter. Aru object distance to hoise minus infinity. So etia ami ki calculate koribo lagibo, lens khoner power to aru focal length. So first ami lens formula to apply kori focal length to calculate korim. So guys, do the calculation by yourself. Okay, now see the solution. 1 by f equal to 1 by v minus 1 by u. Now substitute this 1.5 meter for v and minus infinity for u. So calculation to korar pisot ami focal length to pam f equal to minus 1.5 meter. So now we can easily find the power of the lens, right? Therefore p equal to 1 by f. So jihetu focal length to meter ase, so ako ami convert koribo nalage. Now you can directly substitute it. Therefore p equal to 1 upon minus 1.5. Therefore power equal to minus 0.67 diopter. Hence required focal length is minus 1.5 meter and the power of the lens is minus 0.67 diopters. So guys, the human eye and the colorful world chapter is completed. I hope there is no doubt, and in case if you have any doubt, you can comment below. So guys, completed chapter samuhor notes bur tumaloke amar official WhatsApp channelot pai jaba. So jodi he channel to join hua nai, join hobole hole description boxot eta official WhatsApp number dia hoy ase. He number tut tumaloke eta text kori dile group tut add korai dia hobo. Okay? Alright guys, stay tuned for the upcoming chapter. Thank you.